Good morning. Next is basicity of amines. Basicity of amines. Like ammonia, amines are also basic in nature due to the presence of lone pair electrons on the nitrogen atom. We know that ammonia is basic in nature. What is the reason? Due to the presence of this lone pair electron on the nitrogen atom, it can accept protons. That means ammonia is basic in nature. Similarly, amines are NH2. Due to the presence of lone pair electron on the nitrogen atom, they can accept protons or H plus, and amines are basic in nature. Okay, that's the first point. Now, let us discuss substituent effect on the basicity of amines. Substituent effect on the basicity of amines. Substituent effect on the basicity of amines. Okay, look at here. We know that we are comparing the basicity of primary amines, secondary amines, tertiary amines, and ammonia. Okay, so let us see the basicity of NH3, RNH2, this is primary amine, and R2NH, this is secondary amine, and R3N, tertiary amine. Let us compare the basicity of these amines with ammonia. Look at here. We know that alkyl groups are electron pushing group. That means alkyl groups are plus I effect. They are having plus I effect. That means, look at here. Here I am taking RNH2. RNH2. Here is alkyl group. Alkyl group is having plus I effect, electron pushing effect. That means plus I effect. Because of the plus I effect of the alkyl group, what will happen to the electron density on the nitrogen atom? Since these alkyl groups are pushing these electrons, these bond pair electrons towards nitrogen atom, the electron density on the nitrogen atom will increase. Electron density on the nitrogen atom will increase, and thereby their basicity is also increasing. Now, when you come to the secondary amine, you can see that there are two R groups, there are two alkyl groups, and these alkyl groups are having plus I effect, and hence you can see that the electron density on the nitrogen atom is higher than that of primary amine. That means as the number of alkyl groups are increasing, plus I effect will also increase, and hence what will happen? The electron density on the nitrogen atom will increase. Therefore, it can easily accept proton. That means as the number of alkyl groups are increasing, this is tertiary. As the number of alkyl groups are increasing, what will happen? The plus I effect will increase, the electron density on the nitrogen atom will increase, and hence their basicity will increase. Therefore, the order of basicity of, you can see that NH3, there is no alkyl group, so it is least basic. Okay, there is no alkyl group, there is no plus I effect, it is least basic. Then primary amine, then what is that? Secondary amine, and most basic is tertiary amine. When you compare the plus I effect, in the case of when you discuss the plus I effect, we can see that only on the basis of plus I effect we can see that this is the order of basicity. Least basic is ammonia, and most basic is tertiary amine. What is the reason? In tertiary amine there are two alkyl groups. Alkyl groups are electron pushing group. Electron pushing group will increase the density of nitrogen atom. That means their basicity will also increase. So when you compare only on the basis of plus I effect, so what is that? The substituent effect on the basicity of First one is plus I effect of So here the first we discuss the plus I effect of alkyl groups, plus I effect of alkyl groups. Okay, when you consider the plus I effect, we can see that this is the order of basicity. This is the order of basicity. Okay, keep it in mind. Second factor, so once again this you have to understand. I think hope you understood very clearly. On the basis of plus I effect, we can see that NH3 is least basic, and as the number of alkyl groups are increasing, the electron pushing nature plus I effect will increase, and tertiary amine will be the most basic amine. Okay, now second factor. Protonated, the effect of protonated amine. Effect of protonated amine. What do you mean by the effect of protonated amine? Look at here. Protonated amine means look at here. RNH2. This is primary amine. What do you mean by protonated amine? So when a primary amine takes a proton, so it will accept a proton and it will change into RNH3 plus. This is protonated primary amine. Protonated primary amine. Protonated primary amine. Okay. Now you are having secondary amine is R2NH. Okay, protonated means what is that? It will accept a proton and it will change into R2NH2 plus. Since this electron is using for this bond formation, it will change. It will get a positive charge. Okay, this is secondary protonated amine. This is a secondary cation amine, cationic amine. Okay, this is secondary protonated amine, and R3N tertiary amine. What do you mean by tertiary amine? Protonated tertiary amine. So when a tertiary amine takes a proton, you get protonated tertiary amine. Okay, this is tertiary protonated tertiary amine. Now when you compare the basicity of primary, secondary and tertiary protonated amine, we can see that the order is primary, that means most basic, then secondary, then tertiary. That means the order is opposite that of opposite that of plus I effect. What was the order of plus I effect? When you compare the plus I effect of alkyl groups, you can see that tertiary, most basic. Okay, tertiary, because plus I effect is maximum in the case of tertiary amine. So when you compare the plus I effect, you can see that tertiary amine, then secondary amine, then primary amine. Most basic is tertiary amine. But when you compare the effect of protonated amine, the order of basicity is primary, then secondary, then tertiary. The reason is that in the case of primary amine, why primary amine is most basic when you compare the basicity of protonated amine? Why primary protonated amine is most basic? The reason is that in primary protonated amine, you can see that the number of hydrogen atom is 3. As the number of hydrogen atom is increasing, its ability to make a hydrogen bond will also increase, and hence it will have more stability. So you can see that the primary protonated amine is the most stable one, and hence it is the most basic. And in the secondary protonated amine, you can see that there are only 2 hydrogen atom, and it can make the number of hydrogen atom it can make is less than that of a primary protonated amine. And in the case of tertiary protonated amine, sorry, here it is NH. In the case of tertiary protonated amine, you can see that only 1 hydrogen atom. When the hydrogen atom is as the number of hydrogen atom is less, its stability will also decrease, and we can see that on the basis of protonated amine, when you compare the basicity of protonated amine, we can see that the most basic is primary protonated amine. But when you compare the plus I effect, we can see that the most basic is tertiary amine, because in when you compare the plus I effect, there are three alkyl groups, and because of the electron pushing group, tertiary amine is most basic. But when you compare the basicity of protonated amine, you can see that primary protonated amine is most basic, because in primary protonated amine the number of hydrogen atom is 3, and in secondary it is only 2, and in tertiary it is only 1. So as the number of hydrogen atoms are increasing, what will happen? Its ability to make the hydrogen bond, that ability will also increase. That means they will get more stability. When the cation is more stable, that will have that is more basic. So this is the order of basicity of what is that, protonated amines, or you can write like this: tertiary least, then secondary, and most basic is primary. Most basic is primary when you compare the basicity of protonated amines. Okay, but in the case of plus I effect, the order is reverse. Then third factor. The third factor affecting the basicity of amine is steric factor. Steric factor. Look at here. We have methylamine CH3NH2. You have to compare the basicity of methylamine. Then CH3 twice NH. This is a secondary amine. And CH3 thrice En, tertiary amine, and we have ammonia NH3. We are discussing the basicity of amine on the basis of steric factor. Once again, if it was plus I effect, what was the order? Tertiary, most basic, then secondary, then primary, and least basic is NH3. This was the order when you compare the plus I effect. Okay, now we are comparing the steric factor. When you compare the steric factor, we can see that the most basic is CH3 the twice, CH3 twice NH. Okay, when you compare the steric factor, this is the, okay, here it is. Then you can see that CH3 NH2 primary, this is secondary, then this is primary, then only will come tertiary CH3 thrice N, and the least basic is NH3. Why this order? According to plus I effect, of course, this is the most basic, CH3 thrice En. Okay, because there are 3 alkyl group, 3 plus I effect. But when you come to steric factor, we can see that the most basic is CH3 twice NH, because here you can see that and why, or first you come here, why this is coming in the third position, why tertiary amine is coming in the third position. We can see that here the steric factor outweighs the plus I effect. That means the steric factor is more in the case of tertiary amine. What do you mean by steric factor is more? Since there are 3 alkyl groups, the incoming proton, it is very difficult for the incoming proton to attack the nitrogen. Okay, because due to the presence of a bulky alkyl group on the nitrogen atom, the acceptance of a proton is difficult. That means steric factor outweighs the plus I effect. Even though there is plus I effect is there, but steric factor outweighs that plus I effect. Steric factor is more, and hence the acceptance of H plus is difficult. That is why it is coming here. Now, why this is coming first? Here you can see that the plus I effect outweighs the steric factor. Here you can see that the plus I effect is more. Okay, and hence the plus I effect outweighs the steric factor. Steric factor is less. But here the plus I effect is a prominent factor. Therefore, what will happen? It will become the most basic. And then you can see that here it is primary. Here also there is no steric factor. But here you can see that tertiary will come in the third position due to the high steric factor. And of course, ammonia, NH3, there is no alkyl group, there is no plus I effect. Okay, so least basic is ammonia. Okay, so this is steric factor. Okay, so when you compare different factors, the order is different. Okay, one more example for steric factor. Look at it here. So I think this is very clear to you. When you compare the steric factor, this is the order of basicity. So on the basis of plus I effect, this is maximum CH3 thrice, but on the basis of steric factor, you can see that CH3 twice NH. Then what will happen? CH3 NH2, and then third position only what will come? CH3 thrice N, and least basic is ammonia. Okay. Okay, I think one more example. Let us discuss. We compare the basicity of ethyl amine C2H5NH2 ethyl amine, then diethyl amine C2H5 twice NH. This is secondary. This is primary amine, and you compare triethyl amine NH. So you can see that the order is in this case the order is of course C2H5 twice NH. This is most basic because here you can see that plus I effect outweighs the steric effect. So plus I effect is maximum. Therefore, this is most basic. Then you can see that C2H5 thrice N, and the least basic is C2H5 NH2. Here also a little difference is there. Second, the tertiary amine is coming. The reason is that here you can see that the plus I effect outweighs the when you compare this one, you can see that this one, the plus I effect is outweighs the steric factor. That's why it is coming in the second position. And here it is only one C2H5, and that is plus I effect is very less, so it is coming in the third position, least basic. Okay, so this is the order of basicity of amine when you compare different factors. First one is plus I effect, and second one the basicity of protonated amines. As the number of protons are increasing, the number of hydrogen bond they can make. Therefore, primary protonated amine is most basic, and tertiary protonated amine is least basic, and finally you can see that the steric factor. Okay, thank you.